Hello friends, in the first part of this video, I discussed about the definition of the instruction set architecture, what are the types of ISA and some of its components, right? And in this video, I am going to discuss that the instructions are converted to the binary format before being executed by the CPU, right? And I will also discuss the general architecture of x86 architecture. So let's discuss. And so the actual binary operation being executed by the CPU is encoded in zeros and ones, right? Suppose we write this kind of instruction. So it is a human readable instruction. CPU cannot understand it directly. So CPU, what does it that? It first convert this type of instruction into the binary format in zeros and ones, right? So suppose we have taken example of this kind of instruction. The CPU might compile it to the machine code in this format, binary format, okay? And please don't confuse that it is necessary to convert this type of instruction in this format only, right? It is not necessary. I have taken example this just for your understanding, right? It is a dummy example, okay? So you might confuse that these bytes correspond to AX and BX register respectively, and but the answer is not exactly, right? Let's discuss them in detail. Let's assume that this instruction is in the Intel syntax. I have already discussed what is the Intel syntax, that whether you are using H letter in your instruction, that comes under the Intel syntax, right? Suppose if I write here 1256 H, so this is a Intel syntax format, right? And if I write 0 X 1256, then it is a C style syntax, okay? Both represent the hex value, right? So let's assume this instruction is in the Intel syntax, okay, where this is a format of the instruction. So this instruction tells the CPU to copy the contents of the data of register BX, this BX into register AX, right? So its binary translation is this, okay, the same as this. So this is the first byte, right? This is called byte 1 and this is called byte 2. So byte 1 is called opcode. This tells the CPU that the operation is moving, that is copying, and the direction will be from either from register or the memory to register, right? That is direction will be from BX to AX, and BX might be your register or the memory address, but your destination will be register only, right? So here BX is the source and AX is the destination, right? So this byte is telling the CPU that direction will be from register or the memory to register only, based on the D bit. So I will discuss that this is divided into two parts, this part and the last two bits, right? The last bit and the second last bit correspond to direction and width, right? So here width is means word, that collection of the 16 bit. So here you can see the first part is this and the last part is this. So if D is equal to 1, that means the destination is a register. This is the destination. Destination means AX. Okay. So AX is a register or the destination. And here W is also 1, that means it is a 16-bit word, right? So AX and BX are the 16 bits. Okay. So complete byte means moving the data from register to register of the word size. Okay. So that data will be of word size, that is a collection of 16 bit. Okay. Let's move on to the byte 2. So this is byte 2, the last byte. So it represents mode, register and RM byte. So it is divided into three parts. Okay, so this is a byte 2 in our example. So this byte encodes addressing mode and the registers. So this is the structure: mode, register, right, and RM byte. So here in this example, mode is so here you can see mode, register, and RM. Both are combination of the bytes, right? So mode is a combination of two bytes, which means register to register addressing mode. And register REG means register. It is a combination of three bits, 000 in our case. Okay, 000. So it is representing AX, right? So REG specify the register, either it is uses source or the destination. Okay. So in our case, the AX is being used as a, here you can see AX is being used as a destination, right? And if this byte is this in our example, this 011, it is representing the BX, okay, the last byte or the last register. So this complete byte means moving the data from BX to AX, right? So what does moving from register to register word size means? I have already discussed that this means, okay, word size. So this means this instruction means copying the contents of the data of register BX into register AX, okay. So here you can read from this. So the format of the typical x86 move opcode looks like this. Okay, I have already discussed this. So here I have discussed all the combination of the D and W bits. If both D and W are 1, that means 16-bit move operation, and REG will be your destination. Okay, REG means it is a collection of 3 bytes. Okay, and if D is 0 and W is 1, that means 16-bit move, but in this case REG will be source. Okay, so here you can see all the 4 combination of D and W. Now let's discuss byte 2 in detail. So the mode RM byte tells the CPU that how to interpret the operands. Are they registers, are they memory, or both, and which ones? Okay. So this is the structure which I already discussed about. So this is a dummy example I have taken for just for the sake of understanding, right? The first 2 bytes represents mode. The second, the next 3 bytes represents REG, and the last 3 bits represents whether you are using register or the memory access. Okay. So here mode is 1 1 in our case. If mode is 1 1 means both operands are registered. So here I have already taken all the 4 combination for the mode bits, right? If 0 0 means register indirect. If 0 1 means 8-bit displacement from the register or the memory address. If 1 0 means 16-bit displacement. If 1 1, it means register to register, right? Operation. So register mean it is a combination of 3 bytes 0 0 0. It means AX. So in x86 encoding for REG field, where W is equal to 1 for 16-bit, this is a combination of all the means REG bits. So here 3 it is a collection of 3 bits. So total 2 to the power 3. That means 8 combination are possible. So I have written the register corresponding to each type of combination, right? So here you can read from there. So this is the same as I have already discussed about. Now let us discuss about the general structure of x86 instructions. So x86 instruction can be between 1 to 15 bytes long. As I have already told you that the instruction length is calculated in bytes. Okay. So instruction x86 instruction can be vary between 1 to 15 bytes. So let's discuss about the 1 byte instruction, which is simple instruction, and it consists of clear carry flag, and the machine code will be F8. It is a machine code in binary format. Okay, and it is a just single opcode byte, no operands and no mode RM byte will be there. Okay, now let us move on to the 2 byte instruction like this one. For example, here opcode is this one, and mode RM byte will be this one. So total 2 bytes are there, right? Now let us move on to the 3 byte instruction. Here addressing mode is immediate. So this value, which is a hex value 0x1234, will be moved to the AX register directly. Okay, because it is an immediate addressing mode. And here opcode is B8 for moving AX and immediate. So yeah, immediate value will be 0x1234, but we will not use this kind of value, but because x86 uses little Endianness, so 3412 will be there. I will drop the details and the related concepts of the Endianness in the description box, so you can check it out from here. Okay. So total 3 bytes will be there, one for the opcode and 3412 for the immediate value. So here 34 means low byte of the immediate, and 12 means higher byte of the immediate. So 0x1234 is the immediate value. It is also an example of 3 byte instruction, but here we are taking the displacement also, right? This is the displacement. So I will discuss what is B8 in the last slide, right? I have already created the table for this. So in this example, the opcode is this one, and mode RM byte is this one, right? And here RM byte is BP. So BP is basically a base pointer, right? Which basically points to the parameters or the variables created in the stack memory, right? So here the displacement is the positive 6, right? So total 3 bytes are there. This one, base pointer, and the displacement, right? So in this example, displacement is also being carried out. Okay. So these tips I have already told you in the previous part. That is the part one, right? For x86, for ARM architecture, and for MIPS architecture. So this is the table for them. Okay, B8. So if the register is AX, the opcode will be B8 in hex, and the opcode will be this one in binary format, right? So I have already created the table including all the registers and their corresponding opcode in hex as well in the binary format. So you can read from here. Okay. So that's all for this part. Thank you for watching the video.